When you think of measles, you probably think of childhood illness, something dangerous, something contagious, and definitely not something you would willingly put into your body. However, today I am going to show you that there is actually a very unexpected connection that can be made to the measles virus. The same virus that we vaccinate against might actually become a tool to help us fight cancer in the future. One of the biggest challenges in cancer treatment is that cancer cells mutate extremely fast. They are able to adapt, they're able to learn how to avoid cancer treatment drugs, and they can hide from the immune system in general. That's why even good treatments sometimes stop working. We need therapies that cancer can't easily outsmart. Now, the measles virus is different from most viruses that we know of. Unlike many viruses, it barely mutates. Its surface proteins, or the part that our immune system is able to recognize and respond to, have stayed the same for many decades. That kind of stability is extremely rare, and it means that the virus behaves in a very consistent way. On top of that, the measles vaccine strains have been used safely for decades, so we already know a lot about how those strains interact with the human body. We also already know that weakened forms of the measles virus can enter and kill certain cancer cells, especially those that express particular surface receptors. And it does more than just damage the tumor directly. So, while it does trigger the immune system to wake up, it also causes it to start attacking the cancer. So, measles has this really cool double effect. It attacks the tumor itself, and it helps to rally the body's natural defenses to also attack the tumor. But we still don't fully know which parts of the virus are responsible for these effects. So, even though measles is unusually stable, we do not yet know which viral genes make it that way. We also don't know which parts of the virus are most important for activating the immune system inside of the tumors. So, this lack of information really limits how precisely we can design measles based cancer treatments. So, this is what my project is really going to focus on. So, my idea is relatively simple. We really just want to use evolution itself as the design tool. If we are able to identify the parts of the measles virus that stay stable over these decades, we can use that information as the foundation for safer and more predictable cancer therapies. So, in other words, we let the virus's own evolutionary history show us which parts we are able to trust the most. So, this project has three main phases. So, in phase one, we are going to map out which parts of the measles genome are the most stable over time. So we're going to look at different areas that are passed on from generation to generation. And we are going to look and see which areas are the most consistent, as they are going to be seen as the most essential, stable, and reliable targets for therapy. From there, we're going to move into cancer cell experiments. So we're going to take these measles-based variants and inject them into cancer cell lines and really just look for a couple key things. Do they kill tumor cells effectively? And do they trigger signals that are going to activate the immune system? Some are going to work better than others, and the ones that show strong tumor killing ability or strong immune activation are going to be the ones that move forward into phase three. With phase three, we are going to test the most promising strains in mouse models where human lymphoma cells are able to actually form measurable tumors within the mouse. We are going to inject the virus directly into these tumors and then follow what happens over time. We are going to track if there is any tumor shrinkage, the overall survival of the mouse, and we're going to take a look at how the immune system responds within the animal. This phase really helps us understand whether the therapy is not only effective, but also safe and able to be controlled within a living organism. What makes this approach different is that it does not rely on random trial and error. It uses the measles natural stability, something that evolution has already given us as the main foundation. By focusing on genetic regions that rarely change, we are able to increase the chance that the therapy will behave in a predictable and controllable way. In cancer treatment, that kind of predictability can mean that there are more consistent outcomes for patients and potentially fewer side effects that make it safer. It's strange to think that a virus, once known only as a threat, can become a tool for healing. But by studying how the measles virus has evolved and how it interacts with our immune system, we may be able to turn a past problem into a future solution. So, this project would be one small step towards using evolution guided design to create a safer, smarter cancer therapy. Thank you.